Hello everyone, this is KK Mathematics, the solution to your mathematics. Today we're dealing with binomial theorem. Let's talk about what binomial theorem is. A binomial is an expression that contains two terms connected by a plus or minus sign. So for example, we have two terms here. X is the first term, Y is the second term, and it's connected by minus and plus. So the same applies to this. So because there are two terms, we call it binomial expression. And in this particular example here, we have x, y, and z. And so because we have three terms here, we call it trinomial expression. And binomial expression can be in this form, and it's also binomial expression because well, it's two terms here, and it's all raised to the power 4. And that means that is multiplying this expression. The binomial expression is multiplying itself 4 times. So we shall now describe a far quicker way of obtaining such using the Pascal's triangle. So the coefficient in the binomial function of this expression form a pattern which is useful for small values of n. So using the Pascal's triangle, we consider it. So we have binomial, the coefficient in this function. And the coefficient here, you get to know what it is. Like we have a binomial expression a plus x all raised to the power 0. The coefficient here is 1, and this function is 1 here. The same applies to this. Now, when we consider a plus x all raised to the power 1, the coefficient here is 1 and 1. One thing you need to know here is that the coefficient always starts with 1 and always ends with 1. So, however, this particular case is a different case. That's because what we know that every number or variable all raised to the power 0 or any variable raised to the power 0 gives us 1. And so that is an exception. But however, when you consider this, the coefficient is 1, 1, and our expression will be 1a plus 1x. Now, if we consider this expression, this is a quadratic expression, a perfect square here. So in this particular perfect square, the coefficient here will be 1, 2, and 1. As I said earlier on, that our coefficient is always, as we said earlier on, that coefficient always starts and ends with 1. So in considering the 1, in between the 1 and 1, what we do is that we normally add the previous coefficient. We know that 1 plus 1 gives us 2, and that will be the number that will be in between the first and the last number. And so the expression is this, as you see on the screen. So a squared plus 2ax plus 1s squared. Considering the second expression, sorry, the third expression, fourth expression here, which is a plus x all raised to the power 3, our coefficient will be, as we said earlier on, that it always starts with 1 and ends with 1. And so in between, to find that, what we do is that we know 1 plus 2, we add the previous coefficient, and that's 1 plus 2 giving us 3, and 2 plus 1 giving us 3, right? And we already know it ends with 1. So the expression, this function will be a raised to the power 3 plus 3 raised to the power square, x plus 3 multiplied to x squared plus 1 multiplied to x cubed. Now, one important thing you need to know with this here is that the first term normally carries the highest power in the first term of the expansion. So that's why we have a raised to the power 3 here. And the x comes in always on the second term. So x comes in on the second term. That's what we see here. So one thing to also have to notice here is that when a takes the highest power from 3, it reduces onto the power of 1. So we have a raised to the power 3 plus 3, a raised to the power 2, a raised to then 3 raised, and then we have 1 here. And even this side is even a raised to the power 0. That's why you have this expression there. However, from the second term, s comes in from the second term. And when s comes in, it comes in and increases in power. So we have x raised to the power 1, x raised to the power 2, and then x raised to the power 3 in that order. And the same applies to the rest of them. So in this expression a plus x raised to the power 4, we have this coefficient, and that's 14641. And as we said, we always end and start with 1. And so in getting the numbers in between, what we do is we add the previous coefficient. That's 1 plus 3 giving us 4, and 3 plus 3 giving us 6, 3 plus 1 giving us 4. And that with that, we can then find our expansion. And as the principle applies, when a raised to the power 4, when we start with a raised to the power 4, it actually decreases in power. And the same applies to the x comes in the second term of the expansion and also increases. The same applies to the rest of them. Let's consider an illustrative example here. Now we are told to expand the following binomial expression using the Pascal's triangle. So we have I, which is 2x minus 3y all raised to the power cube, 3. And now I, 2x minus 3 all raised to the power 4. Solution here. The initial coefficients will be 1, 3, 3, and 1. That's because what raised to the power 3, and as we said earlier on, that the coefficient will be what we said that earlier on. So from Pascal's triangle, we know that to be 1 a raised to the power or a raised to the power 3, and as we said, it decreases. Then the s comes in at the second term and increases in power, as you see there. So one thing we need to do here is that we have to replace the a by 2x, because here our first term is 2x, and our second term, which is x, is minus 3y. So wherever we have our a, replace it with 2x, and wherever we have our x, replace it with minus 3y. And so that's what we done here. Put in the brackets, very careful. Now, whenever you have a minus sign, you have to be very careful, because minus is a very dangerous thing. It could lead you to having the wrong answer. So with what we have here, we cube it plus 3 all squared. Now the coefficient, which is 3, wherever we have our a, as we said, replace 2x, and that will be done here. Then minus 3y. Always be very careful with the minus sign. Be attentive to expression of where the minus is. Whenever you're solving a question, make sure you are very attentive with minus sign, because minus sign normally students normally makes mistakes when it comes to minus sign. They normally forget, and that leads them to making mistakes. So that's as you see on your screen there. And so by cubing this function, we know that the cube of 2 gives us 8, and then that of x gives us x cubed minus, we know this is 4. Okay, 2 squared is 4, so 4 times 3, making 12, and then 12 times minus 3, and making minus 36. I told you earlier on that you have to be very careful with the minus sign, because it's very dangerous. Okay, so we do the same for the rest of them. So 2 times 3, 6 times 3, sorry, times 9, right? This is times 9 because there's a square here. And this square here cancels the negative sign, and that gives us a positive value or coefficient. And we do the same for this. This is a cubic function, the cubic of minus 3 and y. And that gives us minus 27. This is minus. We do the same for the I. That's 2x plus into bracket minus 3 all raised to the power 4. With our expression, we have this, so we can then say there's a 16 raised to the power 4 minus 96x raised to the power 3 plus 216x raised to the power 2 minus 216x plus 81. So we have binary theorem for positive integral index. So this is the formula for it. This is the formula we use. So as you see here, a raised to the power n, as we said earlier on, x always starts, always starts from the second term of the expansion. So that's where you see x here, and then it keeps increasing in order, in power. So you think it keeps increasing in power, and that's what we have there. And ends with x raised to the power n, which is the n being the highest power that we have. So that's n combination 1. So the NC1, now you see there's n combination 1 is read as n combination 1, and that is read as n combination 2, n combination 3. And you see that the a raised to the power n minus 1, it keeps decreasing. So we have in the second, in the other term, we have a raised to the power n minus 2, and the other term we have a raised to the power n minus 3, and that goes on and on and on until we, until we get to n minus r. A raised to the power n minus r. Up to what we have there. So, and this can also be rewritten as this: the sum from 0 up to n of n combination r multiplied to a raised to the power n minus r multiplied to x raised to the power r, and this equals this expression there. So n combination r can be written as this. We can rewrite it as this. Okay, so as you see on your screen there. Be very careful. This is not a vector. So as we said earlier on, though that's read as n combination R, and yes. So the n combination R can be simply written as n factorial. Now this symbol that you see here is called factorial, okay, which looks like exclamation sign there, okay, in English. But in Mars, this is factorial. It has a meaning and it's very useful here. Divided by into bracket n minus r, or bracket close factorial multiplied to r factorial here. And n combination 1 equals n, and n combination 2 equals n to bracket n minus 1, or bracket close divided by 2 factorial here. So the next thing we do is to substitute. So wherever we have considering this particular formula here, wherever we have the combination, we replace it with this function here, with this expression here, a simpler expression. So to make things simpler for us, and so back to doing, we have this. So as we saw earlier on, we have n combination 1, and that's we said it's for n. So wherever we have n combination 1 in the expression, replace it with n, and that's what we've done there, replaced it. And n combination 2 earlier on, we said it's n into bracket multiplied to into bracket n minus 1 divided by 2 factorial, and that's what we've done there. So our n combination 2, we replace it with this expression here, a simpler expression to make things simpler for us, and that goes on and on and on until that. So, and we've already explained what this is. 3 factorial means what? 3 times 2 times 1. As in 3 multiplies the decreasing order of the numbers. So 3 from 3 moves to 2 in decreasing order up to 1. So if we have 4, for instance, then we have what? 4 decreasing order, 3, 2, 1. So it's multiplying in decreasing order. So this hold on for, it holds for all positive powers of n. Let's consider important things to note here. The fourth term is always written as this, so be very careful. There is a reason why we want to actually take note of this, and it's mainly because whenever you hear the word fourth term, what it actually means is that one thing you need to note that is that the fourth thing, if you are told to find fourth term, always remember that what the x value, okay, the power should be what? Less than what? The 4. Okay, so here the fourth term, the power here is 3. Okay. So if its number is 3, it's evident in this expression. So if it's the fifth term, sorry, if it's the fifth term, then the power of x will be 4. Okay, 4, which is less than 5. The number is evident. Number 4 is evident. Then the third term is in the term x raised to the power 2, and the second term is in the term x, and the sixth term will be x raised to the power 5, and this goes on and on. Yes, and so the second important thing for you to notice here is that the general term is r plus 1 term, but there is a term containing x raised to the power r, and it's given by this expression here. So n multiplies n minus 1 or multiplies n minus 2 and keeps multiplying until it gets to n minus r plus 1 bracket close, all divided by r factorial, or multiply to a raised to the power n minus r multiplied to x raised to the power 2. Before we start to solve questions under these, it's important for you to subscribe. Please subscribe. If you've not done that, please do so. Click the button there, subscribe to KK Matics right now, and like it. Like it. Click the notification bell and click all, and then like it. Please like it. Now let's move on to an illustrative example here. Now, without fully expanding into bracket 2a minus b all raised to the power 8, we are to determine the sixth term solution here. So using the general term n combination r multiplied to a raised to the power n minus r multiplied to x raised to the power r. So we compare and then find what denote what the variables in the formula here, what they are. So here, in comparing to that expression, here, sorry, we have our n to be 8, and our r here will be 5. Now r here is actually indicating the term that we find ourselves in. In here, we've been told to find the sixth term. So always, as we said earlier on, the sixth term will actually be the power would be the number which is before 6, and that's 5. Okay, And here our a, which indicating or denoting the first term, is equal to 2a. So that's what we have there. Simple. And our x here is minus b. Very careful of minus b. So we have minus b here to be our x, which is the second term here. And always be very careful whenever you have a minus or negative sign there. You have to be very careful because students normally make mistakes when it comes to negative sign. Now we substitute there. So we substitute the various values into where it has to be. So we have our n, which is 8, combination 6 into bracket 2a, all raised to the power 8 minus 5, into bracket multiply 2 into bracket minus b, all raised to the power 5. So we are cautious of the minus b here. So if watching this in our calculator, especially in regarding to 8 combination 6, and that gives us minus 56, and into bracket 2a, all raised to the power 3, because 8 minus 5 gives us 3, and then the minus b. Now, the reason why we have minus or brought minus out is because of the b. Now, we know that b, 5 is an odd number, so we'll have minus still. So that would be minus b raised to the power 5, and so we wrote minus outside. Before all before all this. So punching that on our calculator, we'll have minus 448, especially with the numbers. Of course, be very cautious. So this is 2 or raised to the power 3. So 2 raised to the power 3 giving us 8. So 8 multiplied 56, and that gives us the value here. That is minus 448 multiplied to a raised to the power 3, b raised to the power 5. And we are done with that. So note that the coefficient of the system is minus 448. So that's the coefficient, okay, as we said, the number that is actually multiplying the variable, okay, we given in the question. So we can also make use of this formula, which is n into bracket n minus 1, and this decreases, it multiplies and decreases, okay, so n multiplying what the decreasing, its decreasing function. So this multiplies and keeps on multiplying until it ends with n minus r plus 1. Right, so divided by r factorial will multiply to a raised to the power n minus r and x raised to the power r. So we can then substitute the values into it. Rn here is 8. So you know this decreases. So from 8 up to 7 decreases in 6 and 5 and 4. I recall that these here our r here is 5. So if we were to, so we have our 8 here, so 8 minus r plus 1. So 8 minus r, which is 5, giving us 3. So 3 plus 1 giving us 4. And so we make use of this formula. And so we substitute all the other necessary things, and that gives us minus 448, the same value there. So let's example, okay, example 2. We are told to find the coefficient of the term in x raised to the power 3 of the binomial expansion of into bracket 1 plus 3x all raised to the power 12. Solution here. So using the general term n combination r multiplied to a raised to the power n minus r multiplied to x raised to the power r, where we compare and then find the various variables we have in the formula. So we have n here to be 12, and our first term here is 1, which is the a, and our x here is 3x. So we make use of that. So the term of this function contains s cubed. That means our r is 3. You have to be very careful here. Here, it never stated, this is actually the fourth term, so you have to be very careful here. Instead of saying fourth term, it rather stated x raised to the power 3, which indicates or denotes the fourth term. So you have to be very careful here. So this is a different question. So be very careful here. So we have our r to be 3. Very careful there. So we substitute that into them. So by that doing, we have 12 combination 3 of your star. First term is 1, all raised to the power 3. And we have 3x, which is the second term, all raised to the power 3. Remember, the question said we are to find the coefficient of the term in x raised to the power 3, which is s cubed. And so by using combination formula, we have 12 combination divided by 9 combination, multiplied to 3 combination, times 27. Now 27 is actually obtained from this because we know that 3 raised to the power 3 gives us 27. That's what we have there. And the x is also affected by the cube, and we have s cubed there. So by punching that on our calculator, this simply gives us 4940 x raised to the power 3. So our coefficient here is 5940. We can also use this formula to find that, and that by doing that leads us to the same answer here. Obviously, as I said earlier on, that's the fourth term, and that leads us to the same answer. Simple. Example 3 here. We are told to write down the first three terms and the expansion of this, So consider this. The important thing we need to consider here is we have to expand this, then we have to expand in that. The next thing to do is multiply both expression there. So by using the binomial expansion of a, in bracket a plus x all raised to power n, we have where a equals 1. So here our a, okay, our a is 1. Our a, obviously, we already know what a is. A is the first term, so a is equal to 1. So wherever we have our a, we replace it with 1, right? So by replacing it with 1, we can then have this expression. Okay, so we can then have a general term expression, general binomial term expression, where our first term is 1. So that leads us to this. So wherever we have our a in the earlier expression, we replace it with 1. And so that will be done here, and that leads us to this expression. So this expression is helpful. We can use this expression in finding the binomial expansion of this expression there. So that's what we've done there. Obviously, in the question, we do not want to go far, so we just wrote down the first three terms. So the first three terms is this. This is the first term, this is the second term, and this is the third term. Don't be confused. This is the first term, this is the second term, and this is the third term. Okay, so by so doing, we just have to substitute wherever we have our n. Obviously, in the question here, we have our n to be 10. So we replace our n with 10. And our x value here is x divided by 2. And so that will be done there. And down the same to this one too. So we just have to substitute the various values that we have. So we do that. So we know that 10 is divided by 2, that gives us 5x. Okay, so 2 goes into 2 and 5. And then we also know 2 factorial is 2, because that's 2 times 1, which is 2. And we know 2 goes into 10, that makes it 5. And so 5 times 9, that gives us 45. And all divided by 4. And that's what we have there. So the next thing for us to do is to multiply them. So according to the question, we're given this. So we multiply this to that. So by multiplying that, obviously, we know that this expression here, its expansion is this. And so that's what we have there. The next thing we do is to multiply them. So 1 multiplies all these expressions. We have the same expression because 1 is positive. And obviously, 1 multiplied to any expression or variable or number are the same. They are the same. So we have this expression there. And then the next thing we have is minus 2x. So minus 2x multiplies everything there. So minus 2x multiplied to 1 gives us minus 2x. Be very careful with the minus sign. Minus sign are very dangerous. Always, when you ever come across a minus or a negative sign there, be very careful of that. So minus 2x. So minus there, obviously, in this particular expression, we have all the operation there to be positive. So it tells us that all the operation there. So minus comes in there and changes all the operation to negative. So we don't want to go that far. So we multiply the minus 2x to 1 and minus 2x to 5x, and that gives us this. Because our interest is to write down the first three terms, okay, according to what the question said. And so this is in the third term. And so we don't want to go far. So we end here. So by so doing, we group the items, and group the items, okay, we have 1 plus into bracket, so 5x. We have 5x here and then minus 2x here. We bring them together, so that leads us to 3x. And then we do the same for that one also. For 45 divided by 4, we'll multiply to x raised to the power 2, and that is down to this one too. So as we see on your screen there, and that leads to this answer. So 1 plus 3x, okay, so 5x minus 2x is 3x. And this expression gives us 5 divided by 4 raised to the power, multiplied to x raised to the power 2. Okay, we don't want to continue with the next terms because the question says we are to write down the first three terms of this function. So we've done that, and voila, there it is. Move on to example 4. Example 4, we are told to write down the first 4 terms in the expansion, the cubic root of 1 plus x. So solution there. And using the binomial expansion of this a to bracket a plus x all raised to the power n, obviously, as we stated earlier on, so here we have our first term to be 1. So we state that first term equals 1, and our n here is 1 over 3. Be very careful here. It's a cubic root. So cubic root is 1 over 3. So replace wherever we have our a and n, we replace it. So a replace it with 1, and n replace it with 1 over 3. So by using this general term, because it's just general term, notice that instead of a, we replace it with 1. And so that's what we have to. So we substitute that. Okay, so in comparing to this particular expression, we expanded in that we using binomial expansion formula. We have 1 plus 1 over 3 multiplied to x, and that follows that. Okay, however, we do not want to continue, so we continue up to the fourth term, and you see that the fourth term, this is the term, this is the first term, this is the second term, this is the fourth, sorry, this is the third term, and this is the fourth term. Now you notice the fourth term actually ends with the one that has the x power is 3. Okay, so x power here is 3. So we do not want to go on with the next term, because this is the fourth term. So by so doing, we have this. Okay, we go on ahead to simplify, and that leads us to having this expression here. So 1 plus 1 over 3x plus 1 over 9x squared. Okay, so 2 over 9 is the same as 2 over 9 multiplied to 1 over 2, and so the 2 cancels each other. Then we'll have 1 divided by 9 multiplied to x raised by 2 plus this expression here. Yeah. So voila, there we are. There it is. So we consider example 5 here. So with example 5, we've been told what? The question says that use expansion into bracket 1 minus x all raised to the power 7 to find the value of 1.998 raised to the power 7. And we are told to correct it to 5 significant figures here. Solution here. So using the binomial expansion of a plus x all raised to the power n, obviously we know our first term here in this particular expression here is 1, and our n here is 7, and our x is minus x. As we said earlier on, always whenever you come across minus, be very cautious of it, and your eyes should always be on that, because students normally make mistakes whenever there's a minus sign. So by this we have this expansion. So we just have to substitute the various things that we've done here, we've denoted here. So a, which is our 1, first term here, and n here is 7. So that's what we've done there. So you have 7 there, 7 multiplied to x dot plus this. And as we said, whenever you have the minus sign, always be cautious, and you let your eyes always be on it. So that's what we've done here. And that's up to the fourth term here. Yeah, we do not want to go extra miles. We don't want to continue with the other terms. So we end with the fourth term. So by so doing, we just have to do all extra things. 2 factorial 2 times 1, 3 factorial 3 times 2 times 1, which is 6. And so that cancels that, and 2 cancels the 3, and that leaves us 21 x squared. Okay, now the reason why we have positive x is x squared because of the square. The square actually takes the minus off, so minus minus gives us positive. However, with a cubic function, this is all, so it still leaves us with a minus sign, and that's why we have this. Yep. So by so doing. Now, one thing you need to consider here is that here we were told to use the expansion to find the value of 1.998 raised to the power 7. So one thing you need to consider here, whenever you're given an expression as this, we know that one thing you need to ask yourself is that what value or number are we to add to this to give us 2? Obviously, we know that 0.002 will give us 2, right? So if that be the case, then we'll have to subtract 2 from 0.002. and that will give us this. So we have 2 minus 0.002 all raised to the power 7. And so by bringing 2 out, obviously here the 2 or 2 minus 0.002 bracket close raised to the power 7. The expression, the first term here and the last term here, which is the second term here, it's important for you to note that they all are affected by the power here, 7. And so in bringing 2 out, then always note that that 2 will be affected by 7. So that's why we have the power 7. So 2 raised to the power 7. And since we factorize 2 raised to the power 7 out, we'll be left with, now notice we factorize 2 raised to the power 7 out. And so this also affects this side also, and that's the reason why we are left with 0.001. And so by this, we then say that let x be equal to 0.001. So we compare this to the expansion that we did, and so by comparing to that, so we know 1 minus 0.001, that is equivalent to this. So by this, we'd say that 1 minus 7, so we see the 7 there. The x value here is 0.001, so we just replace the x with the 0.001. Now what we've done here, so we have the 21 multiplied to x squared, so we have 21 multiplied to the x value, which is 0.001 all squared. And this goes on and on and on and on, but we don't want to focus our mind on that, on the terms that follows after. Our interest here is to correct to the phi significant figure here. And so I start doing, 2 raised to the power 7 is 128, and to bracket this expression here, and that leads us to 127.11, and this is to the fifth significant figure here. So that's the first significant figure, the second, the third, the fourth, and the fifth. Okay, so that brings us to the end of today's lesson under binomial theorem. I hope you've enjoyed this video, and please subscribe, like, and share. This is KK Mathematics, the solution to your mathematics. Thank you. Bye for now.